So I tried this in my home lab and honestly the results were insane. It discovered every single network device into NetBox. And literally it took only few seconds with a zero manual work. So if you look at this one, it grabbed the device details, host name, manufacturer and so many other details including the image. And it scanned the whole network. See these loopback IPs we have configured on Cisco routers through Ansible, remember? So when I click on the LAN range, it shows the IPs that are currently active with connected device details. Like this one here, the Ubuntu automation node we have set up on the event chip. And it also shows available IPs that are free to use and so many other details in the IPAM. So NetBox figured everything out by itself and documented in just few minutes, fully automated. So today we will break down and see how exactly this works. I'll decode every components in the solution, what it does and how authentication and integration works and the complete data flow. So by end of this video, you will have a solid understanding on the network discovery solution. And in the next episode, I will demo how to build this step by step from the scratch. And this is going to be a great learning, so let's get started. Alright, let's understand the big picture and see how this auto discovery solution tied together. So there are three main components here. First, we have the ORB agent, which handles the discovery part. Then we have something called DIODE server, which acts as a middleman. And the third and final piece is the DIODE plugin, which is the UI that runs inside the NetBox. So let's dive into the first component, the ORB agent. So this is a lightweight discovery agent that talks to the network device and collects the informations. So there are three different discovery methods available. First one is the network discovery. It uses Nmap behind the scene, which is a network scanning tool, and it scans entire subnet and find the active IP address. Let's say if you tell to scan 192.168.1.0/24 of full subnet, it will ping the every IPs in that range and reports back which ones are live. So this gives a quick map what is active on the network. So now second method is SNMP discovery. This is where it's get interesting. So with SNMP discovery, you will give a subnet to the scan, but you also provide an SNMP community that you have set up on the devices. And the ORB agent will automatically discover every device in that subnet that respond to SNMP. So it pulls the detailed information from each device like the host name, device model, manufacturer and so many other details. And the best part is you don't need to define each device individually on the agent configuration, just give the subnet and the community string. So next comes to the device discovery. And this is required when we need a deep information from a specific device. So it connects to the device individually over SSH using something called NetPAM, a Python library that talks to the network device. So this gives a detailed information like the full running configuration, routing table and all. However, the trade-off is we need to configure each device manually with its IP address, credential and device driver. So in a nutshell, network discovery finds active IPs. The SNMP discovery automatically gets the device details from entire subnet, and the device discovery gives you a deep configuration information from specific device. Alright. Now let's talk about the middleman, the DIODE server, aka ingestion engine. So once the ORB agent collects all the data from our network, it needs to send it to somewhere, right? So this is where the DIODE servers comes in. Think of a DIODE server as a data processing and forward service. It sits between the ORB agent and the NetBox and handle all the communications. So how does it work? First, it receives the data from the ORB agent. This happens over the gRPC protocol. And the ORB agent package up all the discovered device information and send to the DIODE server on the port 5000. On the second step, DIODE server validate and process that data. It makes sure everything is in the right format and ready for the NetBox. And finally, it forward the data to NetBox through the DIODE plugin using the standard HTTP or HTTPS request. So now we have the DIODE plugin, the third component in the solution. So this is the NetBox plugin, meaning it is installed directly inside your NetBox instance and became part of the NetBox UI. So what it does, it receives the processed data from the DIODE server and actually create or update the objects in NetBox. And it also handles the authentication part. So the plugin generate OAuth2 credential that ORB agent used to authenticate with the DIODE server. This ensures only authorized discovery agent can send the data to NetBox, which gives a full visibility and control over the entire discovery pipeline. And there is a DIODE client page on the NetBox where you can manage your OAuth2 credential for the different ORB agents. Alright, now we understand the three main components and how they work together. Next, there are different type of credential used here. So let me break down what each one does. So the first one is the device credential. These are like username, password, SNMP community string that ORB agent use to actually log into the network devices. Pretty straightforward. The important part here is that these credentials live only on the ORB agent configuration file. Next, we have the OAuth2 credential for ORB agent to talk to the DIODE server. So when we set this up, we need to generate these credentials from the NetBox UI under the DIODE plugin. Then we need to copy these credentials and paste them into the ORB agent configuration file. So now ORB agent has these credentials stored locally. And the third type is again OAuth2 credential use DIODE server to talk to NetBox API. And you don't manually create this. When you run the DIODE installation script, it automatically generates these credentials for you. Alright, now we have the credentials set up. Let's see this in action. So what actually happens at the runtime when ORB agent discover a device and send the data through the system? So step 1, ORB agent reads the configuration file, get those device credentials and connect to your network devices. Once authenticated to the device, ORB agent collects all the data and it's sent to the DIODE server. And the next few steps is very important. Now ORB agents create a gRPC request which include all two credentials in the request. So it is sending a client ID and a client secret along with actual device data. Remember, these credentials are available on the ORB agent configuration file. And this is sent to DIODE server. However, DIODE server acts as a middleman. It takes these credentials and make OAuth2 request to the NetBox. So DIODE server send a post request to the NetBox OAuth2 endpoint and says, "Hey NetBox, someone is trying to send a data with these credentials. Are these valid?" So NetBox receives this request and look up the client ID in its database, hashes the provided secret, compares with the stored hash and check if the client is active. And if everything matches, NetBox generate an access token. This is called JWT or JSON Web Token and sends back to the DIODE server. And this token says, yes, this is a legitimate client. Here is a token that prove it, and this token is valid for 1 hour. And DIODE server receives this token and caches it. Now DIODE says, okay ORB agent, you are authenticated, I can accept your data. So bottom line is this token is used to validate the ORB agent's identity. If the token is valid, which is 1 hour, the DIODE will continue to accept the data from the ORB agent without having to revalidate every single time. After 1 hour, DIODE requests a fresh token from NetBox. Now let's go to the step 3. Now DIODE has validated the ORB agent and accepted the data. Now it needs to forward this data to NetBox to actually create the device and the interface object, right? But DIODE can't just start creating devices in NetBox. It needs permission to do that. So DIODE goes through a second OAuth flow, but this time using its own credentials. So DIODE reads its environment file, gets its own OAuth2 credential, which include the client ID, client secret, and these are completely different from ORB agent credentials. And the DIODE makes another post request to the NetBox OAuth2 endpoint and says, "Here NetBox, I am DIODE to NetBox, here is my credential, I need a permission to write to your database." So NetBox receive this request, validate the DIODE to NetBox credential the same way and look up, check the hashes and verify it's active. And if it is valid, NetBox generate a different access token, another JWT, sends back to the DIODE server. The second token says, yes, you are authorized to make API calls to NetBox, and this token is valid for 1 hour. And the diode caches this second token. Now diode has everything it needs. It has the data from the ORB agent. It has the valid access token to write to NetBox. So diode makes an API call, let's say creating a device. This request looks something like this. And NetBox receive this API request, validate this access token, check the signature, check if it is expired, check the permission, and if everything is good, NetBox create the device in the database. Diode continues using this second token for all the API calls, creating interface, assigning IP address, whatever it needs to do as long as it has a valid token. After 1 hour, this token expires. The next time Diode tries to make an API call, NetBox will respond with 401 unauthorized message. And diode sees this and automatically requests a new token using diode to NetBox credentials. Get a new token and retries the API calls, all automatic. Now let me walk through a real example. What happens when ORB agent discovers a device? Let's say I have a Cisco router with an IP of 192.168.1.10 and I have configured an ORB agent to scan that subnet with SNMP. So ORB agent sent an SNMP GET request to 192.168.1.10 asking the basic system information. The router responds with a host name, let's say router name, its model number, serial number, and bunch of other details. On the next step, ORB agent then makes another SNMP request asking all the interfaces. The router responds with gig 0/0, 0/1, 0/2, and so on, include the status, MAC address, and configured IP address. The ORB agent packages all this information into a structured format. It uses the protocol buffers, which is the data serialization format that works with the gRPC. Then it sends this package data to diode server on port 5000 using gRPC. The connection is authenticated using all two credentials we have configured. The diode server receives the data, validate it, and transform into the format that NetBox expects. Then make HTTP post request to the diode plugin endpoint in NetBox. The diode plugin receives this data and start creating objects in NetBox. First it create the device, then set the manufacturer and set the device type, assign the site we configured, set the device role, then it creates all interfaces and finally assign the IP address to those interfaces. So within seconds, I can refresh NetBox and see new router with all its details populated automatically. The whole process from SNMP query to NetBox entry takes 5 to 10 seconds per device. And the beauty is this keep running on schedule. I have mine set up to run every 10 minutes, so any changes in my network are automatically reflected in NetBox. So in the next video, we are going to see how to build the whole system from scratch. We'll install the diode server using the Docker, configure the diode plugin in NetBox, set up our two credential, deploy ORB agent, run our first query and see the device populated automatically. And if you want to follow along and build this yourself, make sure you have the NetBox installed. You can catch up my previous video where I walk through the complete NetBox installation step by step. Alright, that's it for this video. If you have any questions, drop them in the comments below and I'll see you on the next one.